Hello everybody and welcome back. So this is the result of the sim and I'm pretty happy with what I'm getting at the moment. The smoke feels very natural. The only thing that I'm noticing is the velocity injection is quite strong. The amount of pushing down is quite strong. But maybe we have to go back to the source and change that. I don't want to lose too much velocity. I think maybe lowering it to half will just work. And I'm pretty happy with everything. The way the smoke moves, the swirls, the temperature, everything is working great. And because of that decay, because of the zero point 0.8 or 0.7 decay, we see certain microsolvers are only working when there is temperature, and because the temperature is fading off, the effect is gone. And this is very, very important because if we use things like density, they are constant over time. We are going to see that microsolver all the time, and it's going to feel repetitive. It's not going to feel natural. But when we affect the temperature like this, it's going to give us very natural movements. So the next thing for me, I like this. I'm pretty happy with it. I just need to make it better. So I have few things to do. I have three things that I always do. First thing is the vertex confinement node. I always use this. I start with a 0.5 value and go higher as much as I need. This will simply enhance whatever velocity field is doing. It's going to add on top of that. So if there is any curls or any movements like any sharp movements or any fine swirls, it's going to improve that. The next thing is a local sharpening. So I always sharpen the density field and the temperature field, never the velocity field or anything like that. So density and temperature sharpening. And then I layer microsolvers. So we have three to add noise. We have the gas turbulence, we have the gas disturb, and we have the gas shredding. And the most of the time I'm going to affect the temperature field. I don't want to mess with the density because again it's going to give me that weird look, and I try to use the temperature as mask for pretty much everything I do. So let's do this. Let's put down a merge node, and we're going to connect it into the forces, and I'm going to add a gas vortex confinement. And we'll leave it at 0.5. That's the first one. I'm going to disable this, and then gas local sharpen. I want to sharpen the density field, and the default value is fine. And then same one for temperature. I believe we can type in two fields, but I never tried it. And then I'm going to layer a gas turbulence. And the idea here, we have one available in the power solver we're going to use, and I'm going to add a second one on top of this, or two more. So I want large, mid, and small details. Okay, so I'm going to copy this as well. And the first one, I'm going to use a value of, let's say, 0.25. And honestly, we have to, I'll talk about this in a bit, but I'm going to use a small value with a large scale, okay, and then a smaller value than this, which is 0.1, with smaller swirl. So two layers, and I need one more layer, which is going to be in the pyrosolver. So here I'm gonna go to shapes. We have them already. So turbulence. And I'm going to leave it as default. I'm not going to change anything. I just need a size of 1 and the gain of 0.5. And I don't need the density to control this, because right now it's using the density as mask. I don't want this. I want to use the temperature. Okay. And for the temperature, I'm going to say anything that is between 0.1 and 1, activate this node to start giving me the result that I want. Start modifying it. If the range is lower than this, don't do anything else. Okay, so the next thing we want to add, maybe I'll tweak this, is the shredding. So the shredding was not working before because it defaults to the flame. We need to change it to temperature, and I'm gonna leave this the same. I'm gonna lower the pulse length. What this does is there is a noise pattern that generates over time, and it has a frequency. The smaller the frequency, the faster it moves. The smaller the pulse length, the faster it moves. So I'm going to lower that to 0.1. And for the octaves, I'm going to set it to 4 because I want more layers. And then we have the disturbance, and disturbance has two modes. There's a very nice description on the help between the two modes. Basically, the continuous will give us very high details but can cause noise because it affects the voxels directly. The block based is gonna work on local space or locality. It's gonna use 2 voxels, 4 voxels, 8 voxels, 16 voxels, and that's what the grid base block size is for. And I like this one better because if we go between mid and high res, there is a consistency. With a continuous, the result may change, and so it's really up to you which one you use there. Both of them will give you good results if you don't increase the shredding, the disturbance too much. Okay, even if you use continuous and set this to 0.1, you have to make sure that you don't use any high disturbance or anything like that. So we'll lower this to 0.25. For the shredding, I'm going to use a strong value because I want to disturb this temperature field as much as possible, which will give me a nice effect, which will propagate a nice effect. So we'll set it to 10, and then let's go back. This is set. I'm checking something. Okay, so here under the in these two nodes, I'm gonna change the binding here. Instead of let me check. Yeah, instead of density, I'm going to affect the temperature field. Okay, and same here as well. So I'm going to keep these two. And then one more thing, I'm going to copy the large one, and I want to affect the density just a tiny bit, even though I prefer not to do this, but I think in this scenario it's going to help if we have just general movement happening everywhere. So we'll increase this to 3 and make sure that it's not too strong, just enough to get the density moving in an interesting way. And the last one I want to add is a gas disturb. And the default value is quite high, so I'm going to lower this to 4. And this threshold is basically a mask saying that if the data is between this and this, if the control field is between this range, I'm going to use it. And I'm going to set it between 0, 1, and 1. I'm going to leave this to the default, and I'm going to use rotational. So what this means is this node is going to create an SDF. It's going to create an SDF, and instead of pushing the smoke outward and inward, when we tick on rotational, it's going to give us some nice vortices. So it's no longer pushing up and down, it's rotational force, which will give us better movement. Honestly, both mode gives us nice results, but this is what I have. This is what I've been using. And then for the control, right now it's going to affect the velocity field. And the threshold is density. That's fine. I'm gonna use the density as a mask, but we can always change this to temperature and use the temperature if you want to mask this. And that's pretty much it. This is the initial start. So the values that I've set in are actually values that I've tweaked carefully. But what I do when I'm working on this is I start by adding things that I know would work. So for example, I would add these 3 for sure, like those values are solid, and then I would add 1 gas turbulence and tweak it to get the right scale. So the scale I want is going to be relative to the scene, and then I start with 1 value. Once I have tweaked my value, let's say this is my large, okay, then I go from there. Okay, what's the mid? Mid is going to be 1. The swirl size is 1. What is the smallest? Is going to be 0.5 or 0.06. And then the amplitude is going to go. So if this value works well at the scale of 2, and then the other resolution will have a different value. So I start with 1, nail down that it works great, then I propagate and generate the rest of the elements from there. And then the gas disturb I always use. I always have this one because it's going to help with the overall movements of the smoke. So that's it. I'm gonna show a few more tweaks to the solver in the next video to improve the overall behavior of the sim, and then we're going to run a high res sim or a mid res sim similar to what we did, and look at it in the next video. Thank you guys for watching, and see you in a bit.